Welcome incoming students to Belmont's College of Pharmacy for the upcoming school year. My name is Brandon Stevens, and I am a lecturer in Belmont's Mathematics Department, as well as a tutor in Belmont's Math and Science Learning Center. And I'm here, well, not exactly here, but on your screen, on behalf of the Learning Center, in the series of what are going to be several videos that are designed to reinforce and hopefully enhance some of your previous mathematical understanding and knowledge, and kind of go over some of those key concepts that are going to be particularly crucial for your success over the next few years and beyond. So a lot of the stuff that we're going to be covering is stuff like ratios and proportions and unit conversion and dimensional analysis and things that will sound horrifying right now, but hopefully won't by the time that we are done here. But hopefully there's also this secondary goal of kind of getting a general sense of, how to deal with word problems, the bane of everyone's existence. And just in general, a look at how to dive into scenarios with that kind of mathematical perspective. So that's the goal, at least. But without further ado, let's go ahead and get started. This first video is going to be kind of an overview of, ratios, proportions, rates, percentages. What are they? How are they different? How are they really the same? And how we're going to kind of use them to our advantage. Let's go ahead and pull up the whiteboard. So all of these things, rates, ratios, percentages, proportions, all of those things really have to do with equivalencies. The idea of two things being in actuality the same thing in a given context. Those things don't even necessarily have to be the same units. You could say that a unit of distance is the same as a unit of time, or a unit in liquid is the same as a weight, all those kinds of things, saying that they're really the same in whatever context that's being presented in that given moment. So that's what it all kind of boils down to. So let's first start off with the idea of rates. Now, typically, whenever we use the term rates, we're talking about equivalencies where those units are not the same. So equivalencies between two quantities, different things. So, for example, let's say 30 miles per gallon, right? We have a vehicle that gets 30 miles to the gallon or 30 mpg. That's really a hidden rate, because what this is saying is that going the distance of 30 miles is the same as the consumption of 1 gallon of gas, right? Those two things are really the same thing. And typically, the way we would express that as a rate is saying that it is 30 miles over 1 gallon. I've taken this kind of complex unit and really written it as a rate, saying you've got 30 miles is the same as 1 gallon, putting one on top of the other. You can actually see you can actually use the other perspective as well, flipping that fraction and saying that it is 1 gallon for 30 miles is another rate that actually says this same equivalency, saying that the 30-mile distance is the same as consuming 1 gallon of gas. These two things, very different numbers, the same in this different context. That's a rate. So for another example, let's suppose I'm a very in shape person and running is great for me. So let's suppose that if I were to run, let's say 2 miles, and I sweat out, let's say 10 gallons of sweat. Obviously, great example. Definitely not true. I'm not in that much pain. This can be expressed as two different rates, right? We could write the miles over the gallons in that same kind of way. And this is 2 miles per 10 gallons. Or we could write it in the reverse, that 10 gallons over 2 miles. Both rates that express that same equivalence. And both are equally valid, just used in kind of slightly different contexts, right? So in that 30 miles per gallon example, and in this one really, whichever one's on top is typically the one that we are kind of emphasizing in a given situation. So the 2 miles per 10 gallons is really focusing on that distance. The amount of sweat produced, the 10 gallons, is spread out over the 2-mile distance. Whereas, on the other hand, if you have the gallons on top, that's really what's kind of the focal point. I have secreted 10 gallons of sweat over that 2-mile distance. And the same thing with the 30 miles per gallon. We've done the 30 miles on that 1 gallon of gas, or for that 1 gallon of gas, we've kind of done 30 miles. Both are excellent rates, both are very valid for that circumstance because it's just putting one equal thing to another equal thing on top and bottom of a given fraction. Even more so where you'll see this kind of emphasis placement is with the concept of a unit rate. And actually, the 30 miles per gallon is an example of a unit rate because it's just you have 1 as the numerical value on the bottom of your rate. So rate 1 on bottom. So the 30 miles per 1 gallon is already as a unit rate. So 30 miles per 1 gallon. And these are particularly useful and handy to kind of keep in mind because they're good as benchmarks, right? You've got 1 gallon of gas. How far am I able to go? If I'm traveling 60 miles per hour, how far am I able to travel in that 1 hour time frame? It's a good kind of benchmark kind of idea. We could do the same thing with this scenario, right? The 2 miles over 10 gallons, 10 gallons over 2 miles, by just dividing by that bottom part. So we have 2 miles for 10 gallons. Let's say we divide the top and bottom by 10. We can do that because we're doing the same thing to top and bottom, basically dividing by 1. So this is going to be the same as 0.2 miles per 1 gallon. It gives us that benchmark that says we're going to use 1 gallon of sweat to go 0.2 miles. Vice versa, if we have 10 gallons for 2 miles, and we want to express that as a unit rate, we just divide by 2 on top of it. And what that gets us is 5 gallons per 1 mile, giving us that benchmark of saying we've gone a mile, this is how much sweat was produced. That's kind of where you see that emphasis of the top part of our rate really being the emphasis there. So those are rates. Now let's get into ratios. So ratios typically are very similar. It's still about that concept of having 2 things be equivalent, but you don't necessarily have to have the different units on there. Equivalencies, typically similar units. And so a lot of times you can see this used really in solutions, right? So where you're putting two things together and seeing how they're going to combine together in one, mix. So one example is, let's say we just have a class of people, so a typical class. And we have 3 boys for every 7 girls. What this is really saying is seeing a group of 3 boys is going to be the same as seeing like a group of 7 girls. It's going to be a very one-to-one kind of relationship between the two. That's going to be our ratio here. And there's a couple different ways that we can kind of present it. One way, obviously, is with fractions. So we can write this as 3/7. And here we can just talk about them as people, or we could just say boys and girls. Again, so it's not technically the same units. Don't get too bogged down with that. It's still kind of that ratio kind of idea. We can also see it with a colon. That's a very common expression of a ratio, 3/7. Or you can also see it in word form with the word 2, like 3/7, 3 boys to 7 girls, that kind of thing, or 3 boys for every 7 girls, or 3 per 7, all those kinds of things. Those are different expressions of ratios. And it's really saying, again, same thing, 3 boys, 7 girls, kind of an equivalent expression here. And typically, one kind of thing to keep in mind with ratios is it's typically used when you have this kind of part-to-part kind of idea, right? You don't have a total here. You've got 3 boys to 7 girls. That's going to be your ratio of boys to girls. Now, you can also use ratios with the whole kind of perspective, the part of a whole, but typically we refer to those as proportions. So proportions are equivalencies where they are typically similar units, but you have more of that part to whole kind of perspective there. Rather than just having the 2 parts, we're saying, here's the part, how does it compare to the overall picture? And so in that previous example, right, we had 3 boys for 7 girls. If we wanted to talk about the proportion of boys in the class, or even the concentration of boys in the class, if we want to use another term, really we want to talk about the boys as compared to the class as a whole. So consider a group of 10 people. We're going to see that 3 of them are boys and 7 are girls, meaning that the proportion of boys out of the class are going to be 3 out of the total 10 people in the class. That would be our typical part to whole kind of proportion. And again, don't get caught up in the definitions of these and like trying to tell whether this is a proportion or a rate or a ratio. That's not the important thing here. The important thing here is to be able to see these numbers and be able to kind of interpret them in their context and kind of be able to know what they mean, analyze them in the situation, and work with them. So here, 3 out of 10, even though it kind of looks like a rate, we're saying that it's 3 boys out of a total 10 kind of people in this scenario. That's our proportion. You'll also a lot of times see proportions or concentrations as percentages. And so you won't typically see them with colons. You'll sometimes see them, but more so it's usually either as a fraction or a percentage. So fractions, you can see here how we did that. If you want to put it as a percentage, remember that you just divide. So 3 divided by 10 is 0.3. And then we just change it to a percentage by moving the decimal over twice to the right and filling any zeros if necessary. So this is the same as saying 30%. Or the proportion of boys, the boys make up 30% of the overall class. That would be another way of expressing the proportion or the percentage of the boys in the overall group of people. Percentages are actually very handy to work with, and proportions in general, because you can quite easily kind of expand them, right? So in a typical class, there's not going to be 10 people, maybe there's 30 people. So let's say this is a class of 30 people. Where you have that ratio, 3 boys to 7 girls. And we want to know how many of the people are actually boys and how many of them are girls. Well, we already have determined that the proportion of boys is 3 out of 10 or 30%. And so all you have to do is take that proportion or that percentage and then multiply it by the number of people, which would be 30 in this context. And remember that 30% is really the same as 0.3. And if we take that times 30, we're going to get 9 people. And so we can see that this class is going to be 9 boys and 21 girls, right? Because we've got 30 total, 9 boys, so 21 of them have to be girls. This is going to get into some talk of like equivalent ratios and equivalent proportions, which we're going to be taking a closer look at in the next video. But just looking at this percentage, it's a very kind of easy multiply them. You kind of get to that answer. Again, we'll look at in the next video a closer look as to why that kind of idea works. And so there you have it. That is our first video detailing ratios, rates, proportions, and percentages. And the next one, we'll do some more problems and problem solving utilizing these concepts. So check that out.